Hi Olivia. Alright, in this video I'm going to show you how to identify organic compound, right? Organic compound that the question comes in brackets, right? It's very difficult to identify, but in this video I'm going to show you how to identify the names of this organic compound that look a bit complex. If you know you've not subscribed to this page, make sure you do that, or you've not followed this page, make sure you do that and drop a like at the end of this video. I'll stay tuned till the end of this video. Alright, now in the question, we are asked to identify the IUPAC name of this compound. It's an organic compound and it looks a bit complex because it's not a straight chain or it's not fold, right? It is called a compressed structure, right, or a condensed structure. Now this structure, you can see a lot of brackets here, and what do these brackets mean? I'm going to explain to you. Now, first of all, before we can be able to identify this compound, we have to expand this first. The structure needs to be expanded, and this is how to expand a condensed structure. First of all, we have carbon here, first carbon, and it has 3 hydrogens attached to it, so we place the 3 hydrogens attached to it. Second, a bracket. This carbon has bracket. Now whenever you see a bracket and CH2, it simply means that the CH2 is in a linear position, not in a branched position. It's in a linear position. So this CH2 is joined 3 times. So C, this is the first CH2, C and 2H, second and third. And this is what CH2 means, 3 times, 1, 2, 3. Now this particular carbon, it's attached to hydrogen. Now whenever you see CH3 simply means the carbon that is next to it holds this CH3. So it is not like CH2 where it is straight. CH3 is a branch of a particular carbon. So this carbon has CH3 appearing on it twice. So first CH3, 1, 2, 3, and the second CH3. 1, 2, 3. So in summary, what I just said, when you see CH2, it means straight chain. When you see CH3, it means an attachment, right? Hope that is clear. So you can see that this compound is not complex, right? It's just that it's in a condensed form. It looks as if it's complex. Now let's simply name this. First of all, we have to identify the longest chain possible, and then the remaining one that is not included in our longest chain becomes our side chain or our substituent. Now, 1, 2, 3, 4, 5, 6 is our longest chain, right? So this is our chain. And whenever you hear 6 in organic chemistry, it simply means hex. So we're going to write the name hex. Now, hex. And if you look at these compounds, there is no double bond or triple bond attached to it. They are all single bonds. So since they are all single bonds, it means that this is an alkane family. An alkane family naming end is ANE. So since this hex and it's an alkane family, it is now hexane. Alright. Now if you notice that this particular chain here, or this particular compound here, we didn't include it in our longest chain. We just said this is our chain. But this carbon was not included, so this carbon becomes our side chain, and this side chain CH3 is called a methyl group. Now methyl group is attached to a carbon, and we have to identify what position of this carbon is our methyl group attached to. It is simple. The carbon here is, you have 2 options. It's either we start naming the carbon or numbering the carbon from the left hand side or the right hand side, but the branch chain must have the lowest number possible. So let's identify the lowest number possible of carbon here. This is 1, 2, 3, 4, 5, 6. So our branch chain will be on carbon atom number 5, or 1, 2, 3, 4, 5, 6. Our carbon side chain will be on carbon atom number 2. So 5 coming from this side and 2 from this side. So I said the least number possible, which is 2. So if 2 is the least number possible, our numbering will start from here. So this is our first carbon, second, third, fourth, 5th and 6th carbon, not the other way around, because if we move from this side, our side chain will have a higher number which we don't want. So our side chain, which is a methyl group, is attached to our second carbon, so the name becomes 2-methyl. 2-methyl because our methyl group is attached to our second carbon. 2-methyl-hexane. So the name of this compound is 2-methyl-hexane. Have a nice day.